Okay, so this is going to be our lesson 1-2 video for Algebra 2. And here's our 5 essential questions we're going to answer. Oh, well, I guess I should start with the title of the lesson, right? So, two variable equations. So, first EQ, what is the relationship between dependent and independent variables? What is a function? What's the rate of change of a function? And how is it derived or calculated? How can we interchange between slope-intercept form and standard form? And how do we graph two variable equations? And all of this is really just going to be a review of Algebra 1 concepts, right? So here's our first example here, and we're going to go ahead and be addressing EQ 1 and 2 here. So our example is a Jumpy Jeffrey problem. So Jumpy Jeffrey, as you already know, is prone to taking completely irrational risks due to his borderline nonsensical stunts. That said, he tends to have accidents pretty regularly. His BFF, Paranoid Pete, is helping to do some calculations on this to see what it would cost Jeffrey to get Jeffrey a health insurance policy prior to Pete's study. Jeffrey has already had 3 accidents. Since Pete started his study, it seems that every week Jeffrey has 2 accidents. So we're first asked to make a table that shows how many accidents A Jeffrey will have in D days, right? So from 0 days to 28 days. Okay, so let's go ahead and look at that. So at 0 days, right, we'll go ahead and say this is D, this is A, so days, accidents. So at 0 days, obviously he already has had 3 accidents because this is prior to his study. So he already had 3 accidents prior to the study. So when Pete started his study, he already had 3 accidents. So even at 0 days, he's already had 3. Every week after Jeffrey has, or every week in the study, Jeffrey seems to have 2 accidents, right? So every week is 7 days. So 0 to 7 days. So now he's going to be at 5 accidents just because 3 plus 2 is 5. Then at 14, he is going to have 7. And you get the idea of how this is working, right? I hope. So all the way to 28, because that's where we were told to stop, because I don't want to go too far with this. Okay, so now we've got a little true or false problem here. So true or false, the number of days that have gone by depends on the number of accidents that Jeffrey has had, right? So this is ridiculous. The number of days is time, right? Time never depends on anything. Time is always independent of all other variables, right? So this is very much false. So days is our independent variable. I'll just kind of try and write this sideways here. Okay, so independent variable, which means that the number of accidents is our dependent variable. Okay, the number of accidents depends on how many days has gone by. Okay, so that's what we're told about the relationship between time passed and the number of near deaths, right? So the relationship between those two is that the number of accidents depends on or is a function of the number of days that has gone by. Okay, so second example, assuming Jeffrey never spends much time in the hospital, no matter what type of accident he has, maybe he drinks a lot of milk or something, what is the rate of change, or what is the rate at which Jeffrey has his accidents, right? So if it's 2 per 7 days, which is 2 per week, right? And we know that slope or rate is, and actually I think we can go ahead and stop there because it doesn't ask us to find slope yet. So we're just going to go ahead and say that that's our answer for number 1. Okay, so our answer for number 1 is 2 per 7 days. That is the rate. Okay, number 2, in slope-intercept form, now we're going to have to think of it in terms of slope. So our rate of change is 2 per 7 days, right? And slope is given to us as the change in the the change in the dependent variable with respect to the change in the independent variable. Okay, so change in y relative to change in x, or to accidents, right, per 7 days. So our slope is 2 per 7, or 2/7. Okay, that is our ratio of accidents to days, right? So if we're going to write a linear function relative to this problem, well, we got to go back to our table here. Okay, this is important right here. Okay, so this is our days, right? And at 0 days, we already have 3 accidents. Okay, so this is our first point on the graph. And then from here, so at 7 days, at 14, and so on and so on and so on, right? We get higher and higher and higher, all the way out here up to, we'll call this 11. Okay, so what have we got? Well, if we're writing it in slope-intercept form, y equals mx plus b, right? We can simply say that a accidents is equal to m, which we know is 2 accidents per 7 days, times the number of days, right? mx, so y equals mx, and then our y-intercept was 3. Okay, so y equals mx plus b. And another form of notation that you'll see, right? So I said earlier that the accidents are a function of days. They depend on the days. So we can say a of d. All this means is that a depends on d. Okay, and that should look familiar because in Algebra 1, you looked at functions that said f of x equals blah, 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 right? All we were saying is that y is a function of x, or you could even go so far as to say y of x. Okay, same thing really. Not really a big difference there. Okay, so we're asked to graph it, right? And I think that's what this link is for here. Let me see. I'm gonna be super, super depressed. Oh, okay. Here we go. So I can just throw this in here. I don't know if you'll be able to see it on the video or not, but we'll find out, I guess. I'll find out when I go back and try to edit it. Anyway, so what it comes out to is 2/7 times the number of days. So in Desmos, I'm going to use x for the days, plus 3. And there you have it, right? So here's our y-intercept. Okay, and if I go ahead and actually put the numbers into here. Okay, so, let's see, why did I not, there we go. And we see, let me change my settings a little bit more. Let's go by 7. Let me do that. Yep. So we see, if I do a table here, so at 0, it was 3, and at 7, it's 5, and at 14, it's 7, and at 21, it is 9, and at 28, it is, 11. Okay, so we see that same exact deal that we saw when we made the table. Okay, and I'm going to be really depressed if you couldn't see any of that on this video. But in class, we'll have gone over it. Okay, so now we're being asked to write this out in standard form. Okay, so if you don't remember, so slope-intercept form is like so. And standard form is, and use the color coding here, is ax plus by. I'm going to use a capital B. It just bothers me. Equals c, right? And we always want to have this first term be positive if we can help it. Okay, anyway, so how could I do that? So what I'm starting out with is y equals mx plus b, right? Or plus, yeah. So I need to revert it into this form, okay? So a is like y, d is like x. Okay, so I need my variables over here on the left. We already know how to do that. So I'm just going to do minus 2/7 x. So a, and we've got negative 2/7 x, right? Because we want ax plus by equal to c. Okay, so this is what I have so far. The 3 is still left over here, which is fine, but I want this to be a whole number, right? And the only way for me to do that is to multiply both sides of the equation by 7 to make the fraction go away. And I also don't want this to be negative, so I'm going to multiply by negative 7, right? So what that's going to become is, so negative 7 times negative 2/7 d, well, that's going to become positive just 2d minus 7a, right? And over here, I'm going to have equals negative 21. Okay, so that would be my equation here in standard form. ax plus by equals c. Okay, so that's it for this lesson. A relatively short one. Mostly a review of Algebra 1. So what's the relationship between dependent and independent variables? The dependent variable is a function of the independent variable. What is a function? It's the relationship between dependent and independent variables when they're both being associated with the same problem or with the same equation, we can call it. Okay, what is the rate of change of a function? That's just the slope. And how is it derived or calculated? It's calculated the same way you calculate slope. Okay, and I didn't cover it earlier, so I'll go ahead and cover it now. So slope is equal to delta y over delta x, or change in y over change in x. And it can be calculated this way. Okay, or you can just treat it completely as a rate like I did back here, right? Where I knew, find the page, where I knew that my rate of change was 2 accidents per 7 days. Okay, how can we interchange between slope-intercept form and standard form? Just using algebra, simple algebra, just reverting, right? And how do we graph two variable linear equations? Kind of difficult to answer that, but you basically just start with your y-intercept, right? So in this case, it was 3. And then you just graph points that you know that you're going to get when you make a table like so, right? So one of those points, so we went from 0 by 3, that was 1 point. Another point was 28 by 11. Meaning that 28 days, homeboy is going to have 11 accidents. Okay, so that covers it for this video. Any questions that you've got, obviously let me know through email or let me know in class. Always happy to help. Goodbye.